One of the most common uses of quadratic equations is the idea of things being thrown or kicked or dropped or even launched. All those things are called projectiles, and they all follow a parabola shape. So we can use a quadratic equation for them. In fact, these are the two formulas that we'll be using to talk about something that's been thrown or kicked or dropped. It's different if it's feet and meters. It just has a different number in there, either -16 or -4.9. So suppose we threw a ball into the air from a height of 5 feet. Already it's feet, so we know we're going to use this one. With an initial velocity, now velocity is like the speed, and initial just means at the beginning. So the beginning speed of 40 feet per second. So let's go ahead and put everything into this formula in the right spot. H equals -16 t squared. Now h is the height of the object, and t is the time after however many seconds. V sub 0. The way we say that, V sub 0 is kind of like having an x1 or a y1. That 0 just means after 0 seconds, what is its velocity? Well, it's the initial velocity. We haven't done anything yet. It just was thrown, so that's its initial velocity at 0 seconds. Then we have another t, and then we have h sub 0. That means its height at 0 seconds. That's its initial height. So since we threw it from a height of 5 feet, that's a 5. Now what do we do with that equation? Well, we can make a t-table, and we'll use t and h instead of x and y. We're not going to put negatives in because we're not going to go back in time seconds. We'll just put in 0 and then some positive numbers. Now if you go ahead and put these values in, you want to just keep putting values in until you get a value that happens to be below 0. Why? Well, if you graph these, that object starts at 5 feet high, goes up to 29, down to 21, and then by 3 seconds, it's at -19. That means it's already hit the ground, and that last value actually doesn't make sense.